Hello to everyone. I welcome you to my video about summary measures. This is Senior Hannington, your accounting tutor. In today's video, we are looking at how to calculate mean, standard deviation, and the variance. In statistics, summary measures are used to summarize a set of observations in order to communicate the largest amount of information as simply as possible. One of the most important concepts in statistics is that of the expected value, also referred to as the population mean. The expected value of a random variable x is the weighted average of all the possible values of x. We are going to see how to calculate the expected value. Now, the mean of a random variable x provides us with a measure of the central location of the distribution of x, but it does not give us information on how the various values are dispersed from the mean. The other two important concepts, that is the variance and the standard deviation. These two indicate whether the values of x are clustered about mean or widely scattered from the mean. Variance is a measure of how data points vary from the mean. Then standard deviation is the measure of the distribution of the statistical data. How do we calculate variance? How do we calculate standard deviation? How do we calculate the mean? We are going to see how to calculate all those summary measures. I have some formulas here for you. The first formula is that of calculating the expected value, whereby you have to get the summation of all the x values multiplied by their corresponding probabilities. The summation of the values, that is your expected values. Variance, you can see how to calculate the variance. We are going to see that by use of a question. Standard deviation, which is also denoted as sigma, square root of the variance. We are going to see how to calculate that or how to apply that formula using our question here. Don't forget to subscribe to my channel, Senior Hannington, because I'll be uploading a lot about accounting and statistics. Review question. Consider the following information on the expected return for companies X and Y. We have economy, boom, neutral, poor. We have the probabilities. We have the returns of company X as well as the returns of company Y, but these are expressed in percentages. What are the requirements of the question? Calculate the expected value and the standard deviation of returns for companies X and company Y. Expected values, I'll get my returns of each company times the probabilities. Then we get the expected value. Let us start with company X. Company X, we want to get the expected value of returns. Also want to start with company X. So this is what I need. I need the returns with their probabilities. Need the returns with their probabilities. Get the probabilities times the X values. But of course, you expect this figure to be in percentages because our returns are expressed in percentages. 0.2 times 30, that is 6. 0.5 times 10, that is 5. Then 0.3 times 30, that is -9. What is our expected value of returns of company X? We sum up and come up with our figure. So the expected return compound X equals what? That equals to 2. The expected returns of compound X, that is 2. Of course, we also need to calculate the standard deviations of returns for compound X as well. Standard deviation. But before we calculate the standard deviation, we need to first calculate the variance of returns. Variance of returns of compound X. Variance of returns of compound X. Here, what do I need? Simply need all this. I want to calculate the variance first. Then after we calculate our standard deviation, I'll add an extra column. And this will be getting our X values minus the expected value, which is our mean or the mu. The figures we get, we square them, but of course we have to multiply the value we get by the probabilities anyway. Let me show them separately. This is our column. Then I'll insert an extra column, which is probability. This column, which we have to sum up together to come up with our variance. So we start. X values, those are the returns minus our mean, which is 2. So I get 30 minus 2 squared, that is 784. 10 minus 5 squared, 10 minus 2 squared, that is 64. So 30 minus 2. Okay. The negative 30 minus 2, when you square, becomes a positive, that is 1024. 1024. So we have those values, but I'll multiply them with the corresponding probabilities. 784 times 0.20, that gives us 156.8. 64 times 0.5, that gives you 32. Then 1024 times 0.3, that gives us 37.2. What is the summation of this? When we add all this, we get 496. 849, 496. So this is our variance. This is our variance of X. That's our variance of X. So if you want to get the standard deviation, of random variable X, this equals to the square root This equals the square root of the square root of our variance, which is 496. What is that square root? Square root of our answer. That gives us 22.27. That is our standard deviation of returns of company X. I'll do the same for company Y. So for company Y, we start with our expected values of returns for company Y. I'll still use the same information. We want to see for company Y now, that is company X. Company Y. It's company Y. Expected values of returns. Company Y. Expected value of returns. We want to see how we can calculate that. Still, to calculate our expected value, we simply need the probabilities with the outcomes. Those are the returns of company Y. Then we multiply. So I get P times our Y values. But of course, you expect these expected returns to be in percentages due to the fact that returns are in percentages. So 0.2 times 10, that gives us 2.5 times 20, that gives us 10. Then 0.3 times 5, that gives us 1.5. Summation of this gives us our expected returns of company Y. This is expected returns company Y, which equals to what? 1.5 plus 10 plus 2, which gives us 13.5%. That is our expected value of returns of company Y. Of course, we need to calculate the variance before we calculate our standard deviation. So variance of returns. Variance of returns. Variance of returns. Still need the same table here. Variance of returns. Company Y, don't forget. Company Y. Our probabilities are there. Our Y values, they are the returns of company Y. We have the working for the expected returns of company Y. So I need to get my Y values minus the mean, which is our expected value. But this value has to be squared. It has to be squared. So our Y values, the return, that is 10 minus 13.5. This gives us negative 3.5. Then 20 minus 13.5. This is 6.5. Then 5 minus 1.5. This gives you 3.5. So that is our returns minus the mean squared. Then in the next column, we want to see how we can calculate the variance. Of course, I need the probabilities. Y minus sigma bracket squared. Here we get our variance, as we are going to see. Want now to calculate the variance of returns for company Y. This is Y minus the mu squared. Okay, so let us get our variance. Probability is 0.20. 0.20 times negative 3.5. Oh, come on. This was 10 minus 13.5, giving us negative 3.5. When you square this should be 12.25. Then 20 minus 13.5, this is 6.5. When you square, this should be 42.25. And forgot to square. So 5 minus 13.5, that is negative 8.5. Square, that gives us 72.25. Then probabilities times our Y minus mu squared. This is 0.2 times 12.25. This gives us 2.45. Then 0.5 times 42.25. This is 21.125. Then 0.3 times 72.25. This gives us 21.675. When we sum up, we get the variance of our Y, company Y, variance of returns of company Y, giving us 1.125 plus 2.45, giving us 45.22. 45.22. We can now calculate the standard deviation of returns. Company Y. Don't forget to subscribe. If you are watching this video, make sure you subscribe such that you're notified whenever I upload more videos. This is 45.22. Our variance. Remember, the standard deviation is the variance, is the square root of the variance. So square root of our variance is 6.72. That is the standard deviation of the returns of company Y. What next? Calculate the correlation coefficient if the covariance between X and Y is 88. Calculate the correlation coefficient if the variance between X and Y is 88. Now the correlation coefficient and the covariance, these two measure the linear relationship between the two variables. So we have X and Y. So these two, the covariance and the correlation coefficient, measure the linear relationship between the two variables. Correlation, of course, it looks at the strength of the relationship between the returns of compound X and compound Y. But of course, if the covariance is positive, it means that the two variables move in the same direction. And if it's negative, it means that the two variables move in an inverse direction. And of course, if the covariance is positive, then of course, even your correlation coefficient is positive. How would we calculate the correlation coefficient if the covariance between X and Y is 88? Now, correlation coefficient, this is denoted by rho. That is the symbol for correlation coefficient. Rho. Is it that? Rho? Anyway, let me just write correlation coefficient. Correlation coefficient. Correlation coefficient. That is X and Y. Now, correlation coefficient equals to the covariance over the product of the two standard deviations. That is standard deviation of X times the standard deviation of Y. So therefore, this equals the covariance, which is given as 88 over the product of the two standard deviations. That is 6.72 for compound Y times the standard deviation of compound X, which was 22.27. 22.27. When you work out to this, you get a correlation coefficient of 0.58. 0.58. That is our correlation coefficient. And of course, it's a positive correlation coefficient, meaning that there is a positive relationship, though it is not strong, but there is a relationship between the returns of company X and the returns of company Y. That is our review question. In this question, we have been able to calculate the expected values, the standard deviations, as well as the variance. And at the same time, we have also seen how we can calculate the correlation coefficient if the covariance is given. Don't forget to subscribe. And I believe when you subscribe, you won't regret, because I'll be uploading a lot of information about accounting and business statistics. Thank you for watching. This is Senior Huntington. Share the video with your other friends and also tell them about Senior Huntington. Tell them about Senior Huntington's channel. Thank you for watching. Bye-bye.